Okay, so here we have a dynamic programming program from 2012. It's a fairly common type problem. You'll see a similar problem in the textbook and many past paper questions and in an exercise in the textbook. I think the one in the textbook is about clocks, and there's another one about aeroplanes. You'll see various things like this which have this kind of setup. It's called the production planning problem. Which, it's fairly standard stuff really. Okay, so one of the things about dynamic program we must appreciate is that we need to work backwards. If you're not working backwards, you're not dynamic programming, so you will be penalised quite heavily. So make sure we're working backwards. There's a demand of 4 in April. Okay, so that means that obviously if we look in the destination column, we're not going to be storing any at the end of April. Okay, we could have some stored at the beginning, 2, 1 or 0. Of course, there is a maximum of 2 that can be stored, which I think is told there, up to 2 robots. So we can have 2, 1 or 0, and because there's a demand of 4, if 2 are stored, then 2 need to be made to satisfy the demand for April. If 1 is stored, then 3 needs to be made. And if none are stored, 4 need to be made. Right, now before I fill in the numbers, you'll see the set layout different in the mark scheme, slightly different order. Doesn't matter. With dynamic programming, we need to have the correct states, destinations and actions. The order of the rows might vary slightly, and the order in which we write the value column might vary slightly. I'm going to put starred valued for from the previous stage. Any starred values, I'm going to pull those down first. Then the next thing that I will put down is the storage cost. The next thing is overheads. That means for any work, when there's any work being done, there's a £300 overhead. And then extra will be the last thing I put in. If we're consistent, we're not going to get confused as to what the money and the numbers mean. Okay, so let's go through the rows. First row is, there's obviously we're not pulling down because we've only just started dynamic programming, so there's 2 being held in storage, okay, and there is certainly work being done, so there's a 2 times by the 150 for the storage and the work done 300, which is 600. Okay, for the next one, there's only 1 being held in storage, hence the 1 times 150 or just the 150. And there is certainly work being done because we've made 3 that month, hence the 300. There's no extra work done at this stage, so that's 450. And then finally, this one, there's no storage because there's none stored at the beginning of that month. So we're not actually paying for storage now. But we do have overheads because we're making 4. In fact, we have this extra 400, which is referred to any additional labour, it's called, isn't it? So that's extra for labour. Okay, so that's all of stage April covered. We're now on to the next stage, which is March. Okay, now March, again, we could have 2 stored. But if we have 2 stored, we need to make 1, 2 or 3 because there's a demand of 3. Okay, so if we make 2, there'll be 0. If we make 1, sorry, there'll be 0. If we make 2, there'll be 1 left in storage in the destination column for the next month. So that will be pulled for next month. And then if we make 3, we'll have 2 left for storage. And we can't store any more, so we can't make 4. Okay, so we're now on to the next state, which is 1. If we make 1, then we could produce just 2, in which case there's none left in the destination column, which is storage for the following month. We could make 3, in which case there's 1 left for storage, or we could make 4, in which case there's 2 left for storage. Okay, finally, to complete the states, there could be none left in storage. We will have to make at least 3 because there's a demand of 3, as we can say. If we do make only 3, there won't be any left in storage. We can make 4, and there'll be 1 left for storage. We are not allowed to make more than 4. So that's the whole of March, the actual numbers. But let's go for the rows now. The first one, okay, now this is the essence of dynamic programming here. We are pulling down results from before. If we're not doing that, then we're not dynamic programming. So that's the 700 we're pulling from before. We are storing 2, hence the 2 times 150. There is work being done for overheads because there is 1 there, but there's no extra labour costs, so that bit's blank. Okay, so the next month we are pulling the 450 from the previous state because that 1, basically that 1 comes from that 1 there. Okay, so we've got the 450 from the previous stage, state 1, destination 1. Those match. We are storing 2, so hence the 2 times the 150. We are doing some. There are overheads because there is production going on because of the 2, but there's no extra labour cost. Okay. Now the next one, similarly, we can see that there is the 600 being pulled down. Still 2 times 150 because 2 are left in storage, and overheads, no extra overheads because only 3 are being made. Okay, now that's the whole of that state done. We're on to the next row, but before I do that, let's star the optimum one of those and maybe title the optimum one is the 105 because we're seeking to minimize cost. We've already revealed the row from before, 700 from the 700. This time there's only 3 being produced from the month before. So there's only 1 being stored. So hence the 150, and there is production, hence the 300. Okay, now the next row, the 450 is being pulled from before there. The 150 because of the 1 there, and the 300 because of the overheads. And similarly here for the 450, we've got the 600 being pulled, and so on. It's going to getting quite repetitive now. So we'll do that. We've now just completed the state of 1 for March. Moving on to the final state for March, that is that 0 are being held in storage at the beginning of the month. Then we're pulling, obviously, the 0, let's look at the rows here. We're pulling 700 from before. That's 700 there. There's no storage cost. That's why this is blank and this is blank here. Okay, there is extra, there is production being done because of the 300s, and in fact for this one here, there's an extra labour cost here. Okay, so now we've completed all of March. We've starred the 1000, starred the 900, and starred the 1050, which is the optimums for state 2, 1, and 0 for March. Okay, let's just get the next stage is now February. Now February, I know there's a demand of 2, so we need to have 2. Of course, we could have 2, in which case there's no storage and there won't be any left in storage at the end of the month. If we make 1, we'll have 1 in storage, and if we make 2, we'll have 2 in storage. And the numbers go something like this now. So that's the whole of the state of 2 completed. Notice the same thing happening. The pulled down values, the 1050 goes to this one, the 900 to this one, and the 1000 to this one. Okay. And the most optimum here, because we're minimizing, is the 1300. Okay, so moving on to the next state, which is that 1 is held in storage. If 1 is held in storage, then we need to make 1 at least, in which case 0 is left in the storage, and the row looks like that. Okay, we could produce 2 and have 1 left in storage, and then in which case the numbers look like that. Or we could produce 3, in which case we have the maximum left that can be left for storage for the next month, and the numbers look like that. And the most optimum here now would be the 1350. Again, these numbers are all being pulled down from before. The 1000 here is being pulled from the 1000. I've got my cursor over there. And the 900 is being pulled down from this 900 here. And the 1050 is being pulled down from the 1050 there. So that's the whole of that state for February completed. The final state is that none are left in storage at the beginning of February. Now the least that we now need to make at least 2 to satisfy the demand of 2 that we have there. I've just rubbed that there. In which case there'll be none left for storage. If we make 3, there'll be 1 left for storage. We could make 4. It would involve an extra labour cost, as we'll see, in which case the maximum of 2 is held in storage. And then the rows look like this. Okay, so again, notice the pull down starred values from before. Okay, here they are. Okay, so we've now completed the whole of that stage, and we're nearly at the end of this process. Okay. However, let's not forget to star the optimum for each state. That's very important. You will be penalised for not starring your values, so we don't leave us guessing. So we must make sure we star that. Right. Okay. So we're getting to the point where this is all pretty self-explanatory now, I hope. It's the same thing. We've got January. In the month of January, we've got, obviously we have to have 0 at the beginning of January because we've just started. There's a demand of 4, there's a demand of 2, sorry, for January. We could produce up to 4, in which case 2 is left for storage. But if we only make 2, then there will be none left for storage for the following month. And again, we can see the pull down values from the state before, the 1300 from there, the 1350 there, and the 1200 there. Okay, and all the rest follows. And we're looking for the most optimum one here. And that's that one. So now we can actually trace back. So we can trace back. We started off our optimum, our destination is 0 here. So that becomes our state where the optimum one is 1 here. Because we got 0. And the optimum there is 1. And then we're looking to the state, the most optimum for state of 1. Because that's destination from February becomes a state of 1 in March. The most optimum there is also 1. Okay, and now we're just going back to April. So we're looking there at April. That's 1 there. And so the action for each of those rows is highlighted here. Okay, so number of robots that will be made in January, there'll be 2 made because of the 2 here. in